Yes, students, listen. So anyhow, there is no my own handwriting notes. Anyhow, I can manage your class with a lot of example. That only will come for your exam. Sure. Okay. So write the ionization energy. Write the ionization energy. The energy required to remove the electron. Energy required to remove the electron from outermost orbital the energy required to remove the electron from an isolated atom in the gaseous phase. An energy required to remove the electron. The energy required to remove the electron from an isolated atom in the gaseous phase. Yeah, in the gaseous phase from the outermost orbital. The energy required to remove the electron from the isolated atom in the gaseous phase from the isolated atom in the gaseous phase from outermost orbital. From the outermost orbital. That day I discussed, I think, two difference. If you remove the electron from the outermost orbital, you remove the electron from the inner orbital. Right? You remove the electron from the outermost orbital, that is called ionization energy. If you remove the electron from the inner orbital, what is that? What is the energy called? This is ionization energy, right? IE. IE means how much energy required to remove the electron from the outermost orbital of gaseous isolated atom. Right? That is very clear. You remove the electron from the inner core electron also. Is specifically you remove the electron from the inner shell electron. What is that energy? You know about definitely that energy. Maybe you are not thinking, that's why you are not answering. This one very clear, right? And what is this energy called? Any idea? You understood what I am saying? Yeah, this process also is possible because in the research we are doing the removal of electron from the inner shell only, not from the outer shell, because here only we get a lot of information. That energy called binding energy. Okay, binding energy. Binding energy means they remove the electron from the inner shell. You know the shell, right? Shell, K shell. Okay, that shell, inner shell. So because here if you remove the electron, this is not given the information of binding energy. This not completely bind your nucleus, but these electrons completely bind because here all the electrons covered. Okay, therefore this is the binding energy. Okay, so what is the ionization energy means how much energy required to remove the electron from the isolated gaseous atom. Okay, that is ionization energy. So what is a general trend for the ionization energy? What is the general trend it follows from the left to right increasing. Okay, left to right increase and top to bottom decreasing. Okay, left to right increasing, top to bottom decreasing. Why left to right increasing? The ionization energy. From left to right increase the ionization energy, and top to bottom ionization energy decreasing. Why? Students, you try to answer the question that is only meaningful for your listen the class. Maybe any exam is there. Not shell number increasing from top to bottom only. Yeah, ionic radius decreasing, hence the electron ionization energy increasing. Otherwise, the effective nuclear charge increasing. That is a right explanation. From the left to right, effective nuclear charge increasing, E and C. The effective nuclear charge increasing from left to right. When you addition of the electron in the same orbital, same shell, is very close to the nucleus only. Because of tilting the orbitals towards the nucleus side, hence the decreasing the radius of atom and ions also. Hence very attractive force is there with the nucleus and the electron. Therefore, we have to supply more energy to remove that electron. Okay, compared to P3 electron, P5 electron is very close to the nucleus. Hence, we have to supply more energy to remove of that electron. Therefore, from the left to right, ionization energy increasing, and top to bottom ionization energy decreasing because of the principal quantum number increasing, and ionic radius and atomic radius is more. So therefore, ionization energy decreasing. Okay, right. So this is a general trend. Then what happens? You know the ionization energy. For example, if you come for metal or molecules to M plus to M2 plus, and M2 plus to M3 plus. So from here to here, IE1, ionization energy 1. From here to here, IE2. From here to here, IE3. Right? Sorry, IE3. So in that, which one is more energy? You have to supply more energy, either IE3 or IE2 or IE1. You arrange the increasing order. Which one is more, IE1 or IE3? IE3 is more, yes, than IE2. IE2 is more than IE1 because of, if you remove one electron, here more nucleus, less electron. You think about here, more nucleus, less electron. So very tough job to remove of the electrons because M3 plus. So nucleus is more. So 3 electrons you removed already. So how you remove again from the positive charge of the atom? It is very tough, right? You remove from the positive charge 1 electron means how you remove? It is very tough. Therefore, we have to supply more energy. That's why this is the increasing order. IE3 is more than IE2. IE2 is more than IE1. So first job is very easy. When you come for the successive ionization energy, the last ionization energy is a very tough. It is we have to supply more energy, otherwise the third electron is not removed from the positive charges, atom or molecules. Okay, this is a order IE3, IE2, IE1. Some exception case will be there because of when the removal of the second electron to third electron, the half-fill configuration or else it attains the full-fill configuration means there the energy is less. always you have to think about it, the half fit and full fit and a noble gas configuration. There the exceptional case will be there. Okay, right. So next, for example, nitrogen and oxygen. Right? First we take nitrogen. Nitrogen 2, nitrogen plus 2, nitrogen 2 plus, right? This is a IE1, this is a IE2. You compare which one is more, IE1 or IE2? IE2. How you confirm the IE2 and IE1? Similarly, oxygen, you take it, oxygen plus, here oxygen 2 plus, this is a IE1 and here IE2. So here which one is more, IE1 or IE2? So if you compare these two, nitrogen and oxygen, you get some information. For example, here what is our configuration? Nitrogen atomic number 7, 1s2, 2s2, 2p3. When you remove one electron, 1s2, 2s2, 2p2, and here 1s2, 2s2, 2p1, right? Similarly, you compare here. What is the atomic number of oxygen? Oxygen atomic number 8. 1s2, 2s2, 2p4. Now you come one removal of one electron, right? 1s2, 2s2, 2p3. Here 1s2, 2s2, 2p2. Think about it, from half-filled configuration to incomplete. So this is not a very easy job. But here this is a very easy job because this is not a half-filled configuration. Therefore, IE1 is a greater. IE1 is greater than IE2. You got it? But normally what you are thinking, IE2 is greater. No, here it failure because of half-filled configuration. When half-filled configuration means it's a very stable atom. So we have to supply more energy to initiate the removal of electron from the isolated gaseous atom. Okay, and similarly here, this is P4 conformation. When you come here, it is stable conformation. From here to here, very tough job. Therefore, IE2 is greater than IE1. That means IE1 is very easy job. IE2 is very tough job because of half-filled configuration. Okay, and also this is a normal. Always the higher ionization energy is a more than lower ionization energy. So IE2 is greater than IE1 is a normal trend in the oxygen atom, but in the case of nitrogen, it failure. There the IE1 is greater than the IE2. Even though this is a positive charge, from the positive charge you remove one electron, that is a very easy job. Then neutral atom, that is a normal atom, gaseous atom to positive charge. Okay. Correct? So similarly, you may try for phosphorus and sulfur. Phosphorus and sulfur also. Okay, phosphorus and sulfur also. ionization energy of hydrogen is nearly 13.6. Okay, not sure, that is plus or minus, maybe 13.6 is lithium 2 plus hydrogen, helium, lithium. Maybe ionization energy of hydrogen is 13.6 electron volt. Always the ionization energy we measured in terms of electron volt, kilojoule per mole. Okay, anyway. So, but in the case of lithium 2 plus is 9 times higher than the hydrogen. They ask the question why. Reason out this variation. Hydrogen and lithium 2 plus. You know the hydrogen atom. Hydrogen atom is 1s1 conformation. Okay, 1s1 hydrogen. Lithium 2 plus is the same 1s conformation, right? What is the atomic number of lithium? 3. So 2 electrons is removed from the orbital. Think about it. 2 electrons is removed from the orbital means from the 2s orbital you remove 1 electron and 1s orbital you remove 1 electron. So what happened? More effective nuclear charge is there. Okay, 2 plus. So greater nucleus, very less electron. So that electron is very close to the nucleus, hence we have to supply more energy than the hydrogen from the lithium 2 plus. 9 times is higher. So 9 times is higher means almost more than 100 electron volt we have to supply for the lithium 2 plus. The removal of electron from the 1s orbital is very tough here, but in the hydrogen case 13.6 electron volt. Okay, like that the question will come. Next, what are the factors affecting the ionization energy? Okay, factors ionization energy. What are the factors ionization energy? Okay. Oh, you want to write it? So like that question will come. How I discussed the nitrogen and oxygen and IE1, IE2, IE3 and lithium and hydrogen. Like that they can ask anywhere the question. Okay. That series, that row from the nitrogen family, from the oxygen family, anywhere they ask the question. There the first head of the family member, different explanation than the other family group members. Okay, for example, nitrogen and oxygen, that is different, and arsenic and selenium, that is different, because there the contribution of a d orbital and f orbital is there, that is a penetration effect is very less, so screening effect it contribute. So based on that we have to give the explanation. Okay, right. So what are the factors affecting the ionization energy means, you know that when atomic size increasing, what happens to the ionization energy? Decreasing. Yes, decreasing, because the distance is more from the nucleus, therefore you can easily remove. Okay. So therefore, what is that? Atomic size. Yes. Atomic size increasing, ionization energy decreasing, therefore inversely proportional. If you increase the size, ionization energy is very less. And the nuclear charge directly proportional. More nucleus, more ionization energy. That's why nucleus is more means what is the meaning? 2 plus, M2 plus, M3 plus. That is a more nucleus, less electrons. There the ionization energy is more. Therefore, nuclear charge is directly proportional with your ionization energy. Okay, more nucleus charge, more ionization energy. Sometimes the penetration effect also it influences the ionization energy. Penetration effect. Penetration effect also is contribute the ionization energy, which means the s orbital, okay, and p orbital, d orbital, f orbital. So there the ionization energy for pulling the out s electron in the maximum and decreasing pulling the electron from the p orbital. Therefore, the penetration effect s orbital is more, p orbital, d orbital and f orbital. So the removal of the electron from the s orbital is very tough because of that s electron it covers the nucleus. It always surround in your nucleus only. But in the f orbital electron is not like that. It somehow deviates from the nucleus. Okay. Therefore, this is a penetration effect order. So more penetration effect for the s orbital electron. Penetration effect means how much attractive force is there with that electron and nucleus. That is penetration effect. So out of all four orbitals, s electron is very close to the nucleus, or else will cover the nucleus. So more penetration power is there for the s electron. So that we should not remove easily from the s orbital. Then d and f orbital. D and f orbital we can easily remove because of less screening effect. Okay, less screening effect. Right. So these are all the factors affecting the ionization energy. And the electron configuration also, that already you know. Electronic configuration. Electronic configuration means yes, no, half filled and full filled configuration. Okay, more stable. Half filled and full filled configuration is more stable, therefore that is very tough job, and ionization energy is more in that orbitals. So that is electronic configuration also will influence your ionization energy. Okay, right. This one I explained. F minus arrange the increasing order of ionization energy. Arrange the increasing order of ionization energy. ionic radius only explain the isoelectronic. Yeah, this is for ionic radius. Yes, this is a more radius. Sorry, this is the ionic radius, increasing order. I already explained for the anionic species, directly proportional to the charge. If the more charge, more radius. Okay, and in the cationic species, the charge is inversely proportional to the size. More charge means less in size. So this is the anionic species. Which one is more charge, more radius? That's it. Okay, right. Now we come for the next. Electron affinity. So electron affinity is opposite for your ionization energy, because there you remove the electron from the outermost orbital. How much energy is required to removal of that electron? That is ionization energy. But here we add the electron. So neutral atom to negative ion. Yes, we convert neutral atom to negative ion. And the neutral atom to positive ion. Yes, we can do it. Okay. That is a endothermic reaction. That means delta H is positive. Here exothermic reaction. That is delta H is negative. Okay, but this is the first ionization energy and the first electron affinity. When come for the successive electron affinity means that is it won't follow always the exothermic reaction. It converts exothermic into endothermic reaction. Because the first electron addition is the exothermic reaction. Okay, right. So what is the electron affinity? Where is it? Okay, the amount of energy, electron affinity, the amount of energy, the amount of energy, the amount of energy released amount of energy released when an electron is added to the valence shell. When an electron is added to the valence shell. When an electron is added to the valence shell of an isolated gaseous atom. When an electron is added to the valence shell of an isolated gaseous atom. That means if you take X, when addition of one electron, you get the X minus plus energy. Okay, plus energy. So always this reaction is delta H is negative, that is exothermic reaction. Exothermic reaction. Okay, this is for the first addition of electron. Similarly, the last ionization energy is a endothermic reaction, that is first removal of the electron. When come for the successive ionization energy means no, it won't follow the exothermic reaction, endothermic reaction. Okay, right. So this is what is a general trend. As usual, here also the same, from left to right increasing and top to bottom decreasing. Okay, left to right increase and top to bottom decrease. Okay, left to right increasing and top to bottom decreasing. As usual, the same explanation because of the increasing effective nuclear charge in the period and decreasing the effective nuclear charge in the group. When effective nuclear charge decreasing means, so the addition of the electron is very easy because the contact of the nucleus and outermost orbital, not which not considered here the outermost electron, outermost orbital, that is is not more penetration with that nucleus. This orbital is not very close to the nucleus, hence we can add here the series. Okay, period. Therefore, from the left to right, ionization energy increasing and top to bottom decreasing. Okay. Here, if the electron affinity EA is directly proportional to the effective nuclear charge, that means electron affinity is directly proportional to the effective nuclear charge, ENC. More effective nuclear charge means more ionization energy. Yes, we have to give more energy to the system. And electron affinity is inversely proportional to the atomic size. Okay, atomic size and shielding effect, other factors. Shielding effect also. Okay, shielding effect also is a inversely proportional. We arrange the atoms, which one is more electron affinity, decreasing order or increasing order? You order the halogen atoms. Which one is more? F. Any other exception? Any other answer? Arrange the following, that is halogens, either decreasing or increasing order of electron affinity. Which one is more? Iodine, yes, that is least. Okay. Then bromine, fluorine, chlorine. Here only the difference is there. The more electron affinity is fluorine, then fluorine, then this is the order, the first and second. Okay, because of when you add the electron in the f orbital means, that is a fluoride atom, fluorine atom, the electron repulsion is there. Think about it. What is the configuration of fluorine? Atomic number 9. In the atomic number 9, 1s2, 2s2, 2p, 5. Okay, right. But when you add the electron, it attains the noble gas configuration. But for the chloride atom, what is the configuration? 1s2, 2s2, 2p6, 3s2, 3p5. But here, when you add the electron, there is no much electron repulsion when compared with the fluorine atom, because of here empty 3d orbital is there. Orbital is excess, some excess space is there to neglect that electron repulsion. But here there is no space. Here only we add the electron. So the electron, when you add the electron in the p orbital, it's already 5 electron is there. Again you add the electron repulsion is there. So therefore that is, but here not that much repulsive forces because of empty d orbital. Somehow space is there. Okay. Therefore this is more. So that's why here the exceptional case. Other what you are saying, that is that we follow, yes, iodide is a very less electron affinity because of size is more. Okay. So the size and the screening effect is inversely proportional to the electron affinity. Now only we discuss. More size, electron affinity is less. Okay. So what we discussed here, atomic radii, yes, the unit is there, maybe the picometer, nanometer, like that. Ionic radius, yes, unit will be there, picometer, nanometer. And electron negativity, electron affinity, electron volt or kilojoule per mole, yes, unit is there. Because of here, P5 is there. But add the electron, this is P5, right? There is no orbital. Here already 5 electrons are there. Right? You have to add here 4 to 1 electron means the electron repulsion already is there. But here P5 plus 3 electron also is P orbital is there. There is no much continuous Yes. But when we discuss about what we have to discuss, electron affinity. Yes, students, listen. So electron affinity means you understood when addition of the one electron to the isolated gaseous atom, how much energy released from that system, that is a electron affinity. So that delta H is negative, always exothermic reaction. When it comes for the successive, it failure. But in the case of electronegativity, okay, electronegativity. What is electronegativity? Sometimes you get the confusion. What is electronegativity and electron affinity? Electron affinity means when addition of electron, but electronegativity means that is a comparison statement. Here there is no unit for the electronegativity, but electron affinity unit will be there. That is electron volt, kilojoule per mole. Like that, unit is there for your electron affinity. But in the case of electronegativity, there is no unit. That is a comparison statement. Okay, comparison statement. For example, HCl. Okay, HCl. Out of that, which one is more electronegative? More electronegative atom is chloride. So that's why we put the more electronegativity means its arrow mark towards the chloride side. That is the meaning. More electron is there in the chloride side than the hydrogen side. This is a comparison statement. There is no unit for the electronegativity. Electronegativity means del plus del minus separation. Okay, del plus del minus separation. But in the case of homodiatomic molecules, how you can electronegativity? No, there is no electronegativity for chloride, hydrogen, N2. There is no electronegativity, right? So what is electronegativity means? It is a relative tendency of, it is a electronegativity of bonded atom, right? Whatever is there, I dictated because you understood, right? What is electronegativity? Electronegativity means comparative statement. There is no unit for the electronegativity. There we have to say in the molecules means which one is more electronegative than other atom. That's it. Okay, del plus del minus separation when the polarization is happened or else induced polarization. Polarization itself, so much incident is there. Induced polarization. Okay, normal polarization like that. So electronegativity of bonded atom, you write it. Electronegativity of bonded atom. Electronegativity of bonded atom is defined as electronegativity of bonded atom electronegativity of bonded atom is defined as its relative tendency or ability to attract the shared electron pair towards itself. To attract the shared electron pair towards itself. That's it. That is a electronegativity. That means electronegativity means bonded electron, it's going one atom side. That is electronegativity. Here already lone pair of electron is there. That lone pair of electron, it won't contribute for your electronegativity. the bonded, the shared electron pair. So here one electron from the hydrogen, one electron from the chloride, shared and make a bond. But that shared electron pair is close to the nucleus of chloride side, not in the nucleus of hydrogen side. So that oscillation is there between the atom to atom. That is called electronegativity. So when the oscillating electron from one atom to another atom, that is called, what is that? When the electron is oscillate between one atom to another atom, that is polarization. Okay, that polarization is towards one atom side. That means that is electronegativity. Separation of charge. Okay, so here more electron. That is the meaning of the arrow. This one meaning is towards this atom side more electron is there than the straight line. So this arrow mark says where the electron is more. If you give that bond like this, means this side is more electron than the other side. Okay. So as usual, the same trend here also, from the left to right increasing and top to bottom decreasing. The same explanation, effective nuclear charge increasing, therefore electronegativity also increasing. That's why from the left to right, you know the periodic table. From here, so there is a chloride. You leave it the first noble gas configuration here. So chloride is fluoride, chloride, bromide, iodide is there. This is a more electronegativity, because if one electron is more enough to fulfill the noble gas configuration, therefore anybody ready to give the electron means immediately to accept that noble halogen molecules to go for the P6 configuration. Now this is a P5 configuration. Only one electron is more, go for the P6 configuration. Therefore here less electronegativity, here more electronegativity. So therefore alkali metal is a less electronegativity, halogen is a more electronegativity. Okay, more electronegativity. The same as usual, the same explanation we have to give. The electronegativity is directly proportional to the ionization energy and electron affinity. Okay, En is directly proportional to the ionization energy and electron affinity. Okay, I write it shortcut. Electronegativity is directly proportional to the ionization energy and electron affinity, and electronegativity is inversely proportional to the atomic size. Okay, inversely proportional to the atomic size. More size means less electrons. That's why when you come for group wise, the last group is less electronegativity. Okay, less electronegativity. The size is more, electronegativity is less. And electronegativity is directly proportional to the S character. This is a somehow confusion statement. Electronegativity is more when S character is increasing, which means what is the meaning of S character is increasing? For example, sp hybridization, sp2 hybridization, sp3 hybridization. So here the S influence is 50-50%, right? S orbital 50%, p orbital 50%. That hybridized orbital. when you come for here, s orbital percentage is placed, then p orbital percentage. Approximately you can put it, what is that? 33%. Right? Approximately 33% of s orbital contribution. The rest is 64% is p orbital contribution. But when you come for the sp3 hybridization, almost 25%, right? So 25%. So here more s character is there. Here less s character is there. Therefore here more electronegativity. You understood, right? What I am talking about. You got it or not? So s character increasing means electronegativity also increasing. Because of s character is very easy to attract the electron towards itself because of that is near to the nucleus. Okay, near to the nucleus. So you think about it, percentage of s character. Here 50-50. 100% sp hybridized orbital means 50% of s orbital, 50% of p orbital. When you come for the sp3 hybridization, so total 4 orbital is there. So 100% means s orbital contribution 25% only, the p orbital contribution is 75%. Similarly, sp2 orbital nearly 33%. So here more than this one. Therefore, this is more electronegativity. That is the meaning of s character. S character increasing, electronegativity also increasing. Okay. Anything doubt? So that electronegativity we have to calculate based on so much factors. That is Pauling approach, Mulliken approach. Okay. So many factors is there. I don't know. They asked the question for that. And one more, the electronegativity is directly proportional to the bond order. Okay, bond order. Electronegativity is directly proportional to the bond order. So what is the bond order means? Bonding electron minus anti-bonding electron divided by 2. That we will discuss later. Bond order. You know the bond order, right? Bond order means say one atom, one molecule, any molecules, H2, okay, H2, 1H, so 2 electron. This is the bonding electron, right? This is an anti-bonding electron. So therefore bond order is bonding electron minus anti-bonding electron divided by 2. Therefore 2 minus 0 divided by 2 equal to 1. Bond order is 1. What is the meaning of bond order is 1? The bonding from one atom to another atom, H bond H. This is the meaning of bond order. Okay, bond order. So that bond order increasing means electronegativity also increasing. Okay, electronegativity also increasing. What is the time?